Hello friends, welcome back to the another video lecture of ADS subject. In today's video lecture, we are going to learn about AND Queen problem. In previous video lecture, we have discussed about backtracking as well as chain bound. So in backtracking, we have seen some problem which can be solved using backtracking. So here we are going to solve our AND Queen problem with the backtracking. Okay, so let's start. So, AND Queen problem can be stated as follows. Consider a n cross n chessboard on which we have to place n queens so that no two queens attack each other by being in the same row, same column and same diagonal. So as per the chess rules, you know that our queen can attack into its own row as well as its own column as well as its diagonal. So we have to place n queens into our chessboard which can not attack each other in same row, same column and same diagonal. For example, if we have our first queen onto this position, then it can attack onto its same row as well as its same column as well as its diagonal. So this AND Queen problem states that we have to find that places with AND Queen so they cannot attack in same row, same column and same diagonal. So if we have 4 cross 4 chessboard, then we have to place 4 queens onto it. If we have 8 cross 8 chessboard, then we have to place 8 queens onto it. Okay, so consider a problem with 4 queens so that we can easily understand the working of this backtracking problem solution. If we start by placing our first queen on the position 1-1, so here in next step we will place our second queen onto which position, then check that we cannot place our second queen onto this position because it will be onto same column of first queen. We cannot place here because it will be onto diagonal of first queen. So we will put our second queen onto this position. We will go by row for the solutions. The position that have been evaluated and rejected are shown by 0. So these are not possible solution. Then we have put 0 here. Into third step, if we put second queen here, then we will check for the position of third queen. So here this position cannot be selected because it will be the same column of queen 1. Here we cannot put our third queen because that will be same diagonal of second queen. Here also we cannot put our third queen because that will be same column as well as diagonal of both the queens. Here also we cannot put our third queen because it will be the diagonal of second queen. So in that position and that situation requires repositioning of queen 2. Means we have to reposition this queen 2. Okay, so here we have checked first and second place, but that is not available. Then we have put our queen onto this third column, but repositioning is required, so we will put into on the last column. So we have put our queen 2 onto last position. So here again check the right position for queen 3. So here that is not possible because it will be on the same column of queen 1. Here it is possible, then we have put our queen 3 onto this position. Here we cannot put queen on 4 on any position of row 4. Why? Because if we put our queen 4 onto first cell, then that will be column of queen 1 as well as diagonal of queen 3. Here it will be column of queen 3 as well as diagonal of queen 2. Here it will be diagonal of queen 3. Here it will be column of queen 2 as well as diagonal of queen 1. So we have to try repositioning 3, but here we cannot put our queen 3 because it will be the diagonal of 2. Here also we cannot put because it will be the column of 2, and this is not possible. Also we have tried all the possible situation, or we can say all the possible states of queen 2. So that says we must go to the queen 1 and reposition her into the next available position. So instead of this position, we will reposition it and put here. So we cannot put queen 2 onto this position because it will be the diagonal of queen 1. Here also we cannot put because it will be the column of queen 1. Here we cannot put because it will be the diagonal of queen 1. So we will put our queen 2 onto this fourth column. In next, check for the first column. That will be fine for queen 3, so we will put queen 3 onto the first column. And next, for fourth row, we will put our fourth queen onto this position because this will be the column of queen 3 and this will be the diagonal of queen 3 as well as column of queen 1. So we will put our fourth queen onto our third column. So this is the solution. We have put 4 queen onto the 4 cross 4 chess board. Okay, so this is a solution. Here our solution is 2413, which says 2413 are the column numbers as well as indexes are the our row numbers. For example, our queen 1 will be the first row and second column. Queen 2 will be the on second row and fourth column. Queen 3 will be on third row and first column, and queen 4 will be on fourth row and third column. So 2 is a column number and our index of these queens are the row number. Okay, so this is a solution for our 4 cross 4 queen problem. There can be more number of solution of this type of problem. Also with the same technique we can solve 8 queen problem. Okay, so this will be the first tree for our queen problem. Here we have taken 4 queens, so this will be the tree for 4 queens. This we have generated by the brute force approach, and with adding some constraint like no queen will be on the same column, same row as well as same diagonal. So that constraint will make it a backtracking problem, and with that constraint we have solved and find a solution 2413, which is the solution. So this is an example of n queen problem. If you like this video, then like, comment and subscribe. Also share it with your friends. Thank you, friends.